I here? I think I'm here. Hi, guys. Good morning. Uncle Scott here, also known as Uncle Gummy Bear to some. Good to see you this morning. Your mom told me that you guys got a game for Christmas that was kind of about coding and understanding puzzles, and I thought that maybe I could show you guys how that puzzle is kind of like stuff that I do with software when I write it. And so this is kind of like how it actually works in computers, and I'm going to show you a few examples with Python. It's a programming language that's out there that it's not exactly the same, but it's kind of close to types of things that I think probably happen in this game. So I want to show you a few examples. And so if you're interested, here's a few examples in Python here I'm going to show you. So let me make my video of me smaller. That's not the important part here. We're going to show you some coding and see if it helps you see how it relates to the game here. So we're gonna pull up here, and if you can see here, I have a little coding program here. And this coding program right now, it prints out Archer, Reporter, Archer, and Grady's name. And so I'm gonna run it and show you indeed that that's what it does. Put it in this order here. And I'm gonna run this program, and you're gonna see that down at the bottom is where it does the printing. So I know it's kind of boring. It's only doing the printing right now, but it's a good simple way to show you guys how it relates. So anyway, we got Porter, looks like a Star Wars font, right? Got Archer, and we got Grady. Cool, right? All right, so neat. So this program prints that. Well, if we only wanted it to print, say, just Porter, then right here on line 36 that I have highlighted, we're going to temporarily take out Archer and Grady, and we'll add them back. And each one of the names we're going to see here in a second, but just for right now, we're going to take out the Archer and the Grady. We're going to run it one more time. And when we run it one more time, we only see Porter. And then we could do that for each of you, right? So now we're just going to do Archer. And lastly, we'll say print Grady. So pretty simple program. It only does what we tell it, right? Well, what this game is about what happens if you put things in the way, right? What happens if you tell it only print Porter if something else is true? It's kind of like putting like a little diagonal slope maybe on your game here. And so let's say let's only print Porter if something is true, but always print Archer and Grady. So let's find out. Excuse me. Got some cedar allergies here. We're going to say if true, then print Porter. So true is kind of like saying yes, we want to do this thing. And the opposite would be false, right? So I'm going to run this program, and what probably should happen is it prints everybody because it is if it's true. Let me make this a little bit bigger here. All right, make this a little bigger to see. If it's true, then print Porter, and after we print Porter, then print Archer and print Grady. So it does all three. Cool, right? Now, what if we said if false? If we said false, then it shouldn't print Porter, but because we're after the if statement there on line 38 and 39, it's still going to print Archer and Grady. So let's see if that's true. We're going to run it. We run it. Sure enough, we get just Archer and just Grady. So this is kind of like in your game. Let me try and zoom in here. It's kind of like on the game, I think kind of like one of these little green bars that determines where the ball goes. It can either go left or it could go right. And that's like saying if, and then you do something or not do something. So there's another part of if statements called else. Else means what do you do if you don't do the if? And so in this case, I'm going to make an example that we're actually only going to do Porter and Archer right now. We'll bring back Grady in a second. But this is saying if false, so this shouldn't happen, then Porter's not going to print. Else, because we're going to do the opposite of what happened in the if, we are going to print Archer. So this should print Archer. Let's see what happens. Sure enough, it printed just Archer. And it did that because that was the opposite of the if. Now if we change this to true, if we said if true, then that means go ahead and do everything that is in this if block right here. So in this case, because it's if true, it's going to print Porter. And because we did the print Porter, it's not going to do print Archer. So let's see if that's true. I'm going to run it again. I ran it, and then down at the bottom, it's got Porter, right? Cool. So that's the if and the else, which are kind of like these little green things over here. So that's an if and an else. The other thing that you can do in coding that's pretty common, which is kind of like the gears, not exactly the same, but it's similar, is something called a loop. And a loop means do something over and over and over and over. So what if we wanted to print Grady's name 5 times? Well, here's one way we could do it. We could say print Grady, and then we could make 5 copies of it. 1, 2, 3, 4, 5. Maybe we wanted to do it 10 times. 6, 7, 8, 9, 10. Okay, cool, right? And then we run the program. We say print, and it prints Grady a whole bunch of times, 10 times, right? Well, that's one way we could do it. In coding, though, there's a simpler way we can do it. And one of the simpler ways is a loop. So I'm going to get rid of all of these except one, and I'm going to put a loop in to say do this over and over. And so for the loop, I'm going to say, it's called a for loop. So I'm going to say for, and I'll explain what this does in a second. What I'm going to say is for I, which is kind of like just a little counter. Think of it like just like a little number that you're holding. And every time you go through the loop, you add 1 to it. So I went through the loop once, I add 1, 2, 3, 4, and I add, right? So that's what it's doing, is going through a list. That's what this range command here is. You're going to make a list of 0 to 10. So we're going to print it 10 times. And so every time that this loop happens, it's going to print Grady. So here we go. So we're going to run this program and see what happens. And if we look, we printed Grady a whole bunch of times. And this is nice because before we had to say print Grady, print Grady, print Grady, print Grady, print Grady. And now instead of that, we just have these 2 lines to say print Grady over and over. So it's kind of similar to like the gears. As it moves down, it's moving the marble a few times and then it decides when to move to the next step. So that's one way in which coding is similar. And then the last way that I was going to try and compare these here is we're going to make what's called a function. And a function in this land would be kind of like, think of it like it's a group of the purples or the oranges, or you add a few greens in it. And it's a group of gears and ways that the marble can go through that you could add to, say, the next level, or a different thing that you're just playing with. It's like a group of them. That's kind of like a function. It's a set of it's a set of ifs and fors and other things you can do in coding. So we're going to make a function here, and we're going to make a function called print all the boys. Print all the boys, and we're going to say that print all the boys is going to do, it's going to do 3 things. It's going to print Porter, it's going to print Archer, and it's going to print Grady, of course. And we're going to say when print all the boys is called, that's what I want to do. So now we're going to say, in this program, I want to call the function print all the boys. And so we're going to run this, see what happens. And what do we hope is going to happen? What we hope is going to happen is it's going to print Porter, and then it will print Archer, and then it'll print Grady, and then we'll be done. So let's see if that happens. Sure enough, we get Porter, Archer, and Grady. So this print all the boys is kind of similar to like a group of gears and green things here that are moving around the ball. One thing that is kind of similar that I could show you in coding is, let's say, what would happen if you took one of these green things away and then the ball just dropped, right? Well, you can kind of do something similar in coding with something called a return within a function. A return leaves what you were doing and goes back to where it came from when the function was called. So the idea here is that we would want to maybe leave a function early before we do two names. We're just going to do one. So now we're going to say, when print all the boys is called, I want you to print Porter. Then after that, we're going to get out of this function. We're going to leave the function print all the boys, and then we're done. So in this program, what do we expect to happen? Well, we're going to call print all the boys. Print all the boys is going to print Porter, and then it's going to leave. And so we're going to run this with this program and see what happens. So we run the program, and sure enough, we only print Porter. That's the idea, right? So as the final program we're going to run, we're going to print everybody's name. And how about we print everybody's name, how about 1,000 times? You want to do that? Let's do it. We're going to say for I in range 0. Actually, we're going to do it 10,000 times. How about 10,000? 1, 2, 3, 10,000 times. We're going to say print all the boys' names 10,000 times. Y'all ready? Here we go. Hope this doesn't freeze my computer, right? I bet it can bake it. We're going to make it really small so we can see it. So here we go. We're going to say, run the program. Y'all ready? Here we go. 3, 2, 1. Look at it go. And it already got done. That's what's pretty crazy about how fast computers are, is that this printed, and it printed so much text that it said you can only see this much because it already got done. But that only took about a second or two for a computer. So computers are pretty fast, right? Computers are pretty fast. Once they're told what to do, they're very fast. The trick is in telling them what to do. And so Porter, Archer, Grady, Porter, Archer, Grady. I hope you guys enjoy your Christmas presents and you're thankful for them. And I hope you guys have a fun weekend, a weekend off of school. And I hope your teachers are going okay. I know our kids, I think they like their teachers well enough right now. And school is not fun sometimes, but it is good to see your friends and it's fun to learn. So hopefully those parts are good. Oh, and lunch. Yeah, and food is always good too, right? So happy Saturday, guys, and happy Saturday. Bye-bye.